Hello everybody and welcome to this presentation entitled Liberate Your Apps. My name is Philippe Lefma and I'm working for Autodesk Developer Network. This presentation is targeting software developers and programmers who are looking for either getting started with cloud technologies or taking part of their desktop application and take advantage of the new technologies the cloud can offer to us. So in order to get started, I was putting some links there, and this is the main technologies we are going to talk about. The first one is the Windows Communication Foundation, and the other one are focused on two of the most popular cloud providers, namely Windows Azure and Amazon. So before getting started with this presentation, let me introduce you the concept of what we mean exactly by liberating our apps. So for this sample, I choose to illustrate this with an Inventor plugin I was creating previously. So let me switch to Inventor in order to show you a quick demo. So here is Inventor with an assembly loaded in it, and I was using a plugin I worked on a couple of months ago entitled Material Profiler in order to illustrate the Liberate Your Apps concept. So I'm going to click on this button and it displays the user interface of that plugin. The purpose of that plugin is pretty straightforward. You can see here in the left side are a listing of all the materials that are in use in the current assembly. I can expand those folders so we can see the various occurrences that are using this material. And on the right side we've got some additional properties of each material: the name of the material, density, volume, mass, and the percentage of total mass over the mass of the assembly. So in order to illustrate that concept, I was adding two new columns to the user interface of that plugin. So let me scroll that in order to discover those columns. Those two columns are the unit price of each material in US dollar per kilo and the total price of the material, that is just the product of the mass by the unit price. So the interest here is for the user to have always these prices and the total price of the material that is up to date regarding of the current market value, for example, of the material. So if the whole functionality is going to be based on a desktop application, it's obviously challenging to keep this list of prices up to date, because the prices of the material can vary very quickly and very frequently. And for example, if the prices are hard-coded inside the program or based on a separate XML file or some kind of configuration file, then obviously whenever the prices change, each user would need to either update the plugin or update that specific file. So that's why this is a good candidate to host this functionality on web services, and then every time the plugin is started or refreshed, it will use web services in order to grab the actual prices of the material, and then the end user can always have an up-to-date values for those prices. So this is what I did for this sample, and I was developing at the same time the functionality inside the plugin and the web service that will provide the various prices for those materials. So we've got a cloud-based database that is hosted on Microsoft Azure Cloud, and it contains a listing of various materials we have, as well as the price. So for example, we can see the bronze soft tin here as a price of 130, and I would be able to change that price to, let's say, 250. I can as well change the manufacturer or different materials over there, and when I'm done I can commit the changes. So what it's doing is my website is directly connected to this cloud database and is going to upload the new values of the material to my cloud database. If I switch back to Inventor when the update is finished and refresh the user interface of the plugin, then we will see the changes for those materials. Right, I'm going to refresh the user interface and we should be able to see there the new unit price is now 250, and as a consequence the total price of that material inside this assembly as well has been updated. So as an example, we were as well creating desktop clients for this same web service. So you have the full spectrum of clients. The first one is the plugin, the second one is this website I was creating in ASP.NET. Here is a desktop client. I can refresh as well those values, so we can see here the value of the bronze has been updated. And as well, I'm not going to demo that, but we produced an Android client and iOS client if you want to take a look at the samples that are provided with this material. So this is what illustrates the concept that we wanted to highlight here, that is liberating your app from a desktop application and integrating some cloud-based component in order to take advantage of the technology the cloud can offer to enhance your application. So let me switch back to the presentation and go through more technical detail before I'm showing you a demo of those web services. So let's start this presentation by taking a look in more detail at WCF Web Services. That's the technology that will help you migrate part of your application logic to the cloud. So what is Web Services? It's defined by Microsoft as the next generation programming platform and runtime system for building, configuring, and deploying network distributed services, or web services as we call them more commonly. The nice thing with WCF is that it unifies a number of technologies that were provided previously by Microsoft as separate frameworks. So we had ISMX, the previous way of dealing with web services. We had some enterprise services, .NET remoting, messaging, and so on. And the nice functionality about WCF is that it will gather all those technologies, all those functionalities inside a same framework that is going to be much more convenient for developers to get familiar with the technology and work with it. Here are the basics of WCF, and it can be expressed as the ABC motto. So where the A stands for address, so that means where is the service, what is the address that we will use in order to connect to our service. B stands for binding, how do the clients talk to the service, for example, which protocol I'm going to use to talk with my service, HTTP, TCP, and so on. And the C stands for contract, that means what can the service do for a client, or in other words, which are the functionalities that are exposed by the service to the clients. So let's take a look in more detail at those three components. First of all, the contract. And here is the contract, the simple contract I was using in my previous demo. I called that the ADN material, and that's basically a classic .NET class that contains the three properties I need in my example. So that is the name, the price, and the manufacturer. And it's pretty much the same definition as a classic .NET class, except that we are using here some WCF specific attributes like data contract and data member that will specify that this class can be serialized from the service to the client or the client to the service. So that's the first step, will be to define which kind of data we want to exchange between our clients and our server. The second thing to define is the service contract. That's basically, again, a classic .NET interface with methods that are prefixed with attributes like operation contract and service contract that will specify that those methods are going to be exposed as a service. So in that case, we want to be able to retrieve the list of all the materials we have in the database. That the getMaterials method, it returns an array of my materials. Then we want to access a specific material or retrieve a specific material based on this name. That's the second method, the getMaterial. Takes a material name as input and returns a material object. And then the third method will allow you to update or create a new material from the client to the server. So that's the post material. It will take a material object as input and will upload and update that material in the database. When you're done with defining your data and your interface, you are going to implement that interface on the server side as you would implement a classic .NET interface. So that is implementation of each of the methods that are defined inside that interface. Let's talk now a bit about the bindings. So the bindings is going to bind the service contract to the address. So that includes choosing an appropriate transport protocol, choosing how the messages are encoded, what is the data format that is going to be used by our messages, and as well defining how the security works. Concerning the hosting of our service, so we have various options that are exposed by the WCF technologies in order to host a WCF service. The first approach is to self-host the service inside a managed .NET application, so it could be a classic exe console application, but it could be a WinForm application, WPF application, and so on. We can as well host the service inside a Windows service, and as well two other options to host the service inside IIS, so it could be hosted through an ASP.NET website, so that would mean that the service would be associated with a specific website, or direct hosting of the service inside IIS. So let's now take a look at how to create concretely a WCF service. So let's start Visual Studio in order to create a new project, and I'm going to use C# as a programming language, but the same functionality is as well exposed in VB.NET, and I'm going to create a new Windows Azure Cloud Service. So in order to have this template working, you first need to install the specific Azure SDK. I'm going to call that ADN material SRV demo, and when we create a new Azure project, Visual Studio asks us to select through the various web role we want to include inside our new service. So we can see there a list of several ASP.NET web role, and those are to associate a website to our WCF service. And as well, we can use a technology that is called Web APIs. It's a technology that allows you to create REST-based web services, and it's much more straightforward than creating a WCF web service, but at the same time it's less flexible. So here we are going to create a WCF service web role that allows us to create a simple web service without any user interface. I'm going to rename the web role, default web role, into material web role, and I'm going to create my project. So as you can see there in the solution, two projects are created. The first one is the Azure configuration project. So that project will allow us to configure the properties of how our service is deployed on the Azure cloud. And the second project contains the implementation itself of the service. So we can see there that first default service with its interface is created by default. So we can just delete that service in order to create our own. So I delete that default service, and I'm going to add a new item to my project. And this new item is going to be a WCF service. I can select the name of my service here. I'm going to name that material SRV. So when I create a new WCF service, as you can see, there are two files that are created. The first one is the interface, and the second one is the implementation of that interface. So let's start with the interface. And because I don't want to spend too much time typing all the code, I've got here some predefined code samples. I'm going simply to cut and paste this code in order to define my interface and my data contract. So I might have cut and paste the wrong one there. Okay, so here is the declaration of our data contract. So that's the data that is going to transit from the client to the server. And as I was mentioning before, you can see here is a very simple data structure that contains the name, the price, and the manufacturer, as well as the interface that contains our three methods in order to get the materials, get a specific material, and post a material to the database. We are now going to implement that interface, and similarly going to cut and paste the implementation we've got here. And let's check this implementation in more detail. So in the real example I was demonstrating before, the list of our materials are stored inside an Azure table that is a kind of cloud-based database. For the sake of simplicity, inside this sample here we are using a dictionary that will simulate that fake database. So here is our material database as the dictionary, and inside the constructor of our service I'm going to instantiate 3 default materials. So my database contains already some materials. I've got here the gold, the silver, and the copper, and I'm adding those materials to the database. Then the implementation of each method, we've got here the get materials, that is simply returning an array representing all the values in our database. The get material by name is checking if that specific material exists, and it returns that material object. And the post material is checking if the material is already existing in the database, so it will update the value in that case, or it will add a new key and value in the case the material is not in the database. We can now compile our solution, and we can run the debug in order to see if the service is correctly deployed. So the nice thing with the Azure Framework is that while debugging your Azure project, you can see there it will start the Azure debugging environment that simulates the cloud functionalities, and it will deploy locally your service as if it was going to be deployed on the cloud. So you can first start to debug your service locally before deploying that on the cloud. So here our service is now running locally, and if I click on this material srv.svc, then here is the web page that you should see, and it mentioned that we have successfully created a service. Alright, we're now going to add some functionalities to our service, but first let me define some other concepts. The first one is the HTTP request. So as you probably know, the World Wide Web is a web of interconnected resources. Some of the resources can reference each other, and they as well can be of many types, like document, image, services, videos, HTML pages, and so on. In order to uniquely identify a resource, we are using a URI, or Uniform Resource Identifier. The HTTP protocol as well defines 9 methods, also known as verbs, and the one that you are most likely to use are the get, put, post, and delete. Those ones are to retrieve a resource, update a resource, upload a new resource to the server, and delete a resource. There are as well some other verbs that are less used, like the add option, trace, connect, patch, and so on. Talking now about protocols that are used on the World Wide Web, and the first one is the SOAP, that stands for Simple Object Access Protocol. That's a protocol that is used mainly for exchanging structured information through web services, and it was mainly used in the previous technologies of the web services, it relies on XML for the message format and the application layer protocol like HTTP, SMTP for the message transmission. A more popular protocol at the moment is REST, that stands for Representational States Transferred. REST is an architectural style that exploits the HTTP protocol and all the HTTP verbs. It provides an easier way of accessing the data comparing with SOAP, and at the moment is considering as a good solution or the best current solution for interoperability between web services and mobile platforms or browsers. Here is a comparison between REST and SOAP, and we can see that REST is lightweight alternative to SOAP. The reason is that using SOAP you need to use an XML envelope for every part of the data you want to exchange, whereas in REST the URL directly identify the service and as well define the content of your data. So you can see comparison between SOAP and REST identical request on this slide. Here are some further details about SOAP versus REST. SOAP only support get and post action, and all the data in the XML message needs to be provided. So that's the resource to access, function to execute, and so on. REST is using all the HTTP verbs, and as I mentioned, the resource is identified directly by the URI. The function is identified by the HTTP verb. So those are protocols. Let's now take a look at the data format that we can use with those protocols. And the most popular data format at the moment is called JSON, for JavaScript Object Notation. And this is a lightweight data exchange format. JSON is a text format that is easy for humans to read and fast for the machine to parse and generate. That's at the moment one of the most popular exchange format in the web services. Here is a comparison of a JSON message versus an XML message. So let's now take a look at how we can add REST support to our WCF service, and it's pretty straightforward to do. We don't have to actually change the current implementation of the service, but we can just add some web invoke attributes inside the declaration of our interface. So you can see there in that slide, and I'm going to show you how we can do that in our project. So let me switch back to the project. It's still running in debug, so I would need to shut this down, and as well I've got the implementation of our REST interface is there. I'm going to cut and paste that inside our interface here. So we can see that the only thing I was adding is this web invoke method. I specify the web action. Here is a get and post. I specify the URI that is going to be relative to the base address of the service, and the response format is JSON. I will need to add a specific namespace to it. Right, I will now need to update my config file of the service. So here things are getting a bit more technical, but basically what I'm doing is adding JSON support to the configuration of our service. So I'm replacing that whole config file, and we can see here that I was adding new endpoint for supporting REST and JSON. I'm going to compile that project and start it again in order to make sure it's working as expected. Clicking there, and then we can see that our service is running as well. So let's now take a look at how we can actually debug inside the various methods of our service in order to test it locally. I'm going to put breakpoints in the 3 methods of our service in order to make sure they are working correctly. So breakpoint inside the getMaterials, a breakpoint in the getMaterial, and one in the post. So now, because our service is using REST, and REST is natively understood by web browsers, I can simply type the address of our service, so we can switch back to the config file in order to show you what's happening. The address of our service here has been specified as REST, so it means that the address of the specific method will be the base address /rest / the name of the method that has been defined inside our interface, so in that case materials. So I'm going to type the address of that specific method, so here I'm using rest /materials, and while invoking that method inside the browser, then you can see that the breakpoint is hit inside my getMaterials method, and it's going to return to my browser a JSON string that represents the list of all my materials. So here we can retrieve our gold, our silver, and our copper. Let's now test the material method. So for that, let me go back to the implementation of our interface, and in that case the syntax is material /material name. So I'm going to type there, let's say I want to retrieve the gold, so I'm going to type material /gold, and as you can see, I'm breaking inside my getMaterial method that will return a JSON string representing only that specific gold material. So now I'm going to test the post method, and it's a little bit more technical because I cannot directly build a post request from my browser, but instead I would need to rely on a third-party add-in or functionalities, and a good one is Fiddler. It's a little bit more technical to use, and another good solution is the REST add-in that is provided with Firefox. So here is the interface of my REST add-in, and I'm going now to build a post request in order to upload a new material to my database and test my post method. So here the add-in lets me specify the method I want to use, so it's going to be a post, the URL of my service, so I'm going to reuse that same URL here. That's the URL of our service, and here we need to build the body of the request. So for that, got as well some predefined. So here is a new material. I'm going to set the manufacturer to Firefox. And it's going to be the steel material. The price is 100. And as well, I would need to add some headers to my request. So here I specify that the content type is going to be JSON. So let me edit that to application/JSON, and I will send that request to my service. So we can see here instantly the post method is getting invoked, and if I check the content of the material, I can find my material, Firefox, steel, and the price 100. So by doing that, let me remove now breakpoints there in the get material. I'm going to use that same add-in in order to perform a get request now. So that's the get request. The body of the request is empty. I want to retrieve now the list of all my materials. I specify materials there, send that request, and here I should be able to see the list of my various material. And we can now see that my database contains the 3 basic default material plus that material I was just adding with my post request. So it illustrates how you can easily debug locally your service before putting that on the cloud. So let's now take a look at how we can deploy that web service on the Azure cloud. I will first stop the debugging of our solution, and I will create a package that can be uploaded on the Azure cloud. So I select the package option here, build configuration, set to debug, service, configuration to cloud, and I'm going to create a package. So inside that package I will get basically 2 files. The first one is the config file and the second one are the binaries. Here is my package, so we can see the configuration file there and the package file containing the binaries of my service. And now I'm going to log inside my Microsoft Windows Azure account in order to create that new service. So here is the dashboard of Windows Azure, and you can see here the various functionalities that it offers to you. You've got website, virtual machines, mobile services. In that case we want to create a new cloud service. So here are the list of the service that I already get running. So I've got the viewer, and that's the material service I was using as a previous demo, and I'm going to create a new service for that. A new cloud service, custom create. I'm going to call that ADN material demo. Here you can select the region of your service. In that case we will keep that for West US. The subscription, and I want to deploy the cloud service package now. So it will prompt me the deployment name, ADN material demo as well. And here I will select my package and configuration file created from my Azure project. So I was cut and pasting the path already. So here is my package file and the configuration file. I'm going to deploy even if one or more role contain a single instance, and start the deployment now. Here you can see you've got the choice between production and staging, and this allows you to deploy a service in production and then deploy a new version of the service in staging, and then swap the staging and production, and then continue and maintain the service to your user while you are updating, replacing a new version of that service. I'm going to click complete there, and in a couple of minutes the service is going to be deployed. So I'm going to pause the recording and come back when the service is running. Alright, our service is now running, so I can click on that to enter the configuration, and if I click on the URL then I should be able to see that my service is running. So we can see that the service seems to be alright, and in order to test it, so similarly to what I did locally, I can invoke my REST method in order to get all the materials from my service, and here we can see the reply of the online service. So let's now quickly create an executable in order to test this service. Show you that it's very straightforward. So I'm going to add a new project, and it's going to be a C# executable, so WinForm application. I'm going to call that material client, and I'm going to simply to access the service inside the load events of my form. And it's pretty straightforward to add a service reference using Visual Studio, so we can use the add service reference option, and I'm going to specify the address of my service there. So that would be ADN material demo cloudapp.net material service.svc. So when I click on the go, then it should retrieve my service. You can see there my material service with the operation it provides, and I'm going to change that, for example, to material SRV. That's the base namespace of my service. You can see it's adding a service reference to it. I'm going to specify I'm using the material client dot material SRV namespace. I'm going to create material client, SRV client here, that is going to be my service client, and I will instantiate that client inside the load. Here I could provide the endpoint configuration name. So in order to retrieve the endpoint configuration name, I need to check in the app.config file that's been created when my service reference has been added. And so here is a little bug, because obviously the web-based address of my service is not correct, so I would need to replace that with the actual address, that is this one. I'm not sure about this this issue, but I'm going to use in that case the sub-version of my service. Back to our code here, I'm going to specify this endpoint, and I'm simply going to retrieve the list of all my materials. So I would need an ADN material array, invoking the getMaterials method on my service, putting a breakpoint over there in order to check the results, setting that project as the startup project, and running the thing. Alright, my breakpoint has been hit, and if I check the list of the materials, I can see it contains 3 materials when I retrieve the gold, silver and copper from my service running on the cloud. So that's closing our demo for this presentation. Let me quickly show you the various code samples providing with the material along this recording. So we've got the ADN material viewer, Android project, that's the Android client that will connect to my material database service. There is the same thing in iOS. We've got the material profiler add-in, that's the inventor add-in I was demoing at the beginning of this presentation, and the cloud project that contains the various projects that composing the cloud service. So inside that we've got the ADN material client, the desktop client, the material service and its web role, and as well the ADN material web, that is the ASP.NET website I was demoing as well at the beginning of this presentation. So that's finishing our Liberate Your Apps demo. I hope you enjoyed that presentation, and I wish you good luck in order to develop your cloud-based web services. Thank you.